No, I just barely got it open. I got the menu printed.
Mine is like it's like This is all
So I emailed out a topic review. Did you all get that? Okay. Okay, shall we? All right. All right, so we want to be able to multiply and divide power series. And then we'll see, once we're done learning how to do this, how we can use it. So let's take a look at the following function. F of x equals x times cosine cubed x. All right, and let's say that we want to find the Maclaurin series for this. Well, we could go through the formal process of finding the Maclaurin series, which would be to use the formula, right? Which means we'd have to make like a table of derivatives and then evaluate each of the derivatives at 0 because it's a Maclaurin series, right? And that would help us try and come up with a formula for that constant out front. However, we actually know the Maclaurin series for cosine, don't we? Now, cosine of x, we don't have the Maclaurin series for cosine of x cubed, but we can use the formula, and that formula you have on your, I see it right there. What is the Maclaurin series for cosine of x? It's sum n equals 0 to infinity. Negative 1 to the n. X to the 2. Cosine, yeah, 2n, and then over 2n factorial, right? That's our cosine. All right, and if we write that out, if we start writing out the first few of these, we should get 1 minus a half x squared. I'll put 1 over 2 factorial, even though it's still a half, plus 1 over 4 factorial x to the 4th, plus 1 over 6, minus 1 over 6 factorial x to the 6th. I'll do one more. 1 over 8 factorial x to the 8th, right? So that's the first few terms of our Maclaurin series for cosine. So what we're going to do is we're going to come over here and we're going to rewrite this as x times this thing. But instead of plugging in x, what are we going to plug in? X cubed. So everywhere we see an x here, we're going to replace it with x cubed. So it's going to look like this. 1 minus 1 over 2 factorial x what? X cubed squared. X to the 6th, right? We're going to multiply those exponents, and then we have plus 1 over 4 factorial x cubed to the 4th. So x to the 12th, and then minus 1 over 6 factorial x to the, where are we here? So 18th, and then plus 1 over 8 factorial, plugging in x cubed, so x to the 24th, right? Plus dot, 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 close parentheses, right? That's what we have. And then, yeah.
Why did you put the x on the outside?
That's the original,
Oh,
right? This x right here.
Yeah, for sure.
And now let's just distribute the x through, right? Just distribute that x. So we'll have x minus 1 over 2 factorial x to the 7th plus 1 over 4 factorial x to the 13th minus 1 over 6 factorial x to the 19th plus 1 over 8 factorial x to the 25th plus dot, dot, dot. So there it is. That is the Maclaurin series for x times cosine of x cubed. So what we've done is we've done some multiplication, right? That's about as easy as it ever gets right there, because we're just all we did was wrote the series out using the formula and then multiplied that by x, right? Okay, so let's try something a little bit harder. Ready? Okay, how about this? How about let's leave this up here, okay? And let's change that a little bit. So what I'd like to change this to is, let's take that x out of the front there. And let's do cosine of x cubed times e to the 2x. All right? So we want to find a Maclaurin series for this. So again, we have a formula for cosine, right? Do we have a formula for e? We do, right? Now I'm going to write that over here. That's on your little cheat sheet. E to the x. Now this time, I'll write the sum out. Sum n equals 0 to infinity, and it's 1 over n factorial x to the n, right? That's your formula for it. But if you start writing these things out, you should get 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. That's all on your formula sheet, right? It even has the first few written out. Okay? All right, so let's do this. This should be equal to, well, cosine of x cubed, we did that in the previous example, right? So let's write out what we had gotten there. We had 1, then it was minus 1 over 2 factorial x to what power? 6th. And then it was plus 1 over 4 factorial x to the 12th. And then minus 1 over 6 factorial x to the 18th. Plus 1 over 8 factorial x to the 24th, right? And then plus dot, dot, dot. It keeps going, doesn't it? So I'm going to say plus dot, 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 and I'm going to close the parenthesis. That's the cosine of x cubed. And now I have to multiply that times the Maclaurin series for e to the 2x, which is another parentheses with a bunch of stuff, dot, 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 right? Okay, so I'm going to run out of room here, so I'm going to start getting rid of some of this stuff. Now be careful on this next part. We want to do e to the 2x, right? So we're replacing, in our formula, we're replacing all the x's with 2x's. So let's see what we would get. 1 plus, what? 2x, okay, and then plus 1 over 2 factorial, and then we have 2x squared, right? Which would be 4x squared. Okay, plus 1 over 3 factorial, and now 2x cubed, which would be 8x cubed, right? Yes? Plus 1 over 4 factorial, and now 2x to the 4th, which is going to be 16x to the 4th. Any questions? 1 over 5 factorial times what? 2x to the 5th, so 32x to the 5th plus dot, 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 close the parentheses. Any questions? Luis, we're okay? Everyone understand where all that 2x, 4x, all that stuff came from? Sure? Chris? Okay, now we have to multiply these together. So how do we do multiplication of polynomials? Like back in the day, you know, if someone gave you like x plus 1 times x plus 2, right? You would just FOIL it, right? But if this was like, I don't know, x squared plus x minus 1, how would you multiply those? You don't use FOIL anymore, right? Like FOIL goes away. So the proper name for this is expansion. We're expanding this. So the technique is this. You start with the first term and you distribute that through to every term over here. And then you move to the second term and distribute that to every term. All right? That's what we have to do. All right? Now, obviously there's an infinite number of terms, right? So we cannot do this forever, but we can at least get a feel for what it looks like. All right, so here we go. This is equal to. All right, so watch how I do this. Actually, I'm going to move this up just a little bit. All right, let's start by taking the 1 and distributing that 1 through, right? And what would it create? It would just create that again, right? Okay, so watch the way I write this, okay? Since this is our first example, watch the way I write this. I'm going to write 1 plus, now if you think about the powers of x, do you all agree that as I move through here with this 1, the powers on my x's, I have all of them covered? In other words, this first term is x to the 0, then x to the first, x squared. If for some reason this skipped some of the powers, I would leave a gap in here. So for example, if this was 2x squared, what I would write on my next piece, I would write 2x squared. I would leave a gap in here for my x terms. All right? Now I don't need to because that has all the powers of x, right? You'll see in another example when I do one. Okay, but for this I have every power accounted for. Do we want to clean these up or just leave them? You want to clean those up? Okay, that's 4 over 2, so that's 2x squared. Okay, plus, okay, what's this one? 8, there's a 2 in here, right? So 4/3, 4/3 x cubed. And then over here plus, let's see, 4, 2, 8, so 2/3 x to the 4th. Do you all know what I'm doing there? I mean, it's just some arithmetic on that to figure out what that is. Okay, this one, so it should be 2/15, if I'm not mistaken, plus 2/15 x to the 5th, plus, okay, right? I'm just going to say plus. And I'm going to stop because that's where I stopped here, right? Now I'm going to move to the next one. So now I'm going to go this one, right? Here times here. So that times 1 is what? Minus, yeah, so I need to add that in here, right? So normally what you would do is just keep adding along here, but I'm going to start a line underneath this, all right? So I have 1 times this is just that, right? I'm going to line it up with the x to the 6's, which I don't have any x to the 6's. Do you all see that? So underneath here is where they would be. So I'm going to put here minus 1/2 x to the 6th. Do you all see that? And now I do this times this. So what would that give me? Just it would be a minus, right? It'd be a minus, and then just x to the 7th, right? What would my next one be? This one times this one. No, I missed it. Sorry, that one right there, right? So what was the number in front of this? This was really 4/3, right? 4/3, and I'm multiplying it by 1/2, so what's that going to be? 2/3. So 2/3, and it'll be minus 2/3 x to the, x to the what? Did I miss?
Plus 3.
Hold on, x to the 6th. I've already messed myself up. Hold on. This times this is this, right? This times this was this. And then this times this one, right? I didn't do this one yet. Sorry, I skipped this one, right?
Should be a 1/2, right? Is it?
I got too many lines here. Hold on. Let me back up. Okay. All right, this one right here times that we've got, right? Okay. This one times that. The 2's cancel, you get x to the 7th, and there's a minus. That's this, right? And now we have this times that.
Which is 2x squared. It's 1, 4. Yeah. Not 2/3.
Just 1, right? No 2/3 there? So
2x squared.
what I should do is just get rid of this. This is really what?
Oh, I'm looking. Oh,
2, right? That's really a
I was
2?
looking at.
And this is really a 1/2. So half of that, half of 2 is 1. And then x to what power? X to the 8th. All right? And then I could keep going, right? I'm going to stop there. I'm going to look at the next multiplication through. What would my next multiplication through here be?
1, 4.
This one, right? This one times this one, right? Oh, times that one, which would be x to the 12th, right? Which would be way down here, wouldn't it? Right? It would just be like x to the 12th, or 1/4 factorial x to the 12th. And then after that, you would have higher powers of x, wouldn't you? And then if I went to the next one, to here, what would I have? 18th, which would be way down there, right? Something like, whatever factorial x to the 18th. So what you normally look at with the power series when you multiply them is just the first so many terms. Like, let's just look at the first 3 terms. Could we say with confidence that the first 3 terms of that power series are those 3? Or is there something else that we're going to get? Are we going to get another constant or another x to the first power, another x squared if we keep multiplying these out? We won't, right? Because these powers keep going up, right? And these powers keep going up. So these are the only 3 pieces we're ever going to get that have either a constant, an x, or an x squared. Did y'all see that? The only part that really changed was right in here. Like, don't we have another term here? So we would have to put those 2 together. But this expression, cosine x cubed times e to the 2x, if you wanted an approximate power series, 1 plus 2x plus 2x squared plus 4/3 x cubed plus 2/3 x to the 4th, that is a pretty good approximation because we know anything pretty much from here on is not changing. Does that make sense or not? Doesn't seem like it does. So let me do another example. I think if I do another one, it'll come to light a little better. Let's try this one. How about f of x is sine x, and then times e to the x squared. Let's just do that. All right, so we want to find a Maclaurin series for this. Let's get it accurate within the first, 4 terms. But once we go through it, I'll determine how many terms we want. So first I'm going to rewrite sine. Sine rewritten is x minus 1/3 factorial x cubed plus 1/5 factorial x to the 5th minus 1/7 factorial x to the 7th plus ... Do y'all agree with that? That's your Maclaurin series for sine of x, written out. And then now your Maclaurin series for e to the x squared. So that would be 1 plus x squared plus 1 over 2 factorial x to the fourth plus 1 over 3 factorial x to the sixth. Do y'all know where I'm getting these from? This is the time to ask right here. Just the sheet, right? Replacing the x with x squared. Plus 1 over 4 factorial x to the eighth plus dot, dot, dot. Okay? Now let's multiply. Starting with the x. The x through to here, what's that? X. So I'm going to leave a gap here. Notice I left a gap here in case I ever get a constant. On the next multiplication through, if I ever get a constant, I'm going to leave a space for it. What's the next one through? I get x cubed, right? So notice I'm going to go plus x cubed. See that? I left a gap here in case I pick up an x squared later. Here to here. 1/2 x to the fifth. I left a gap for any x to the fourths that I might pick up. Okay? Let's keep going. What's the next one? 1/6 x to the seventh. I left a gap. Next one. 1/24 x to the ninth. I think that should be okay. All right, that's what I get my first multiplication through. Ready for the second multiplication? Okay, what does that give you? Negative 1/6 x to the third. So I'm going to put it underneath right here. This is my x to the thirds. It's negative 1/6 x to the third. Okay, my next multiplication goes here to here. So what's that going to be? Minus 1/6 x to the fifth. I put it under x to the fifths, right? Next one. So 1/6 times, so 1/12 negative x to the seventh. Okay, now I want you to just think about it. Let's say that I only want the first 4 terms, all right? The first 4 terms of this power series. So if I would have told you here, first 4 terms. Do I need to keep going with this multiplication of the red one? No, because the next one is going to be x to the ninth, which is out here, right? My first 4 terms are only going to include these, right? Maybe. Let's see. What happens on our next multiplication? Let's go this one now. Here to here. What power am I going to get? X to the fifth. I need to include this one, don't I? So what's that going to be? 1 over 5 factorial. What's 5 factorial?
60. Times 2 is 120.
120. So that's going to be 1 over 120 x to the fifth. So that's going to go under the fifth powers. So plus 1 over 120 x to the fifth. Do y'all see that? Yes? Okay, what about the next one? Here to here. What power am I going to be at? 7. Do I need it? I do need it. If I want the first 4 terms, I'm going to need this one, right? So what is that going to be? 1 over 120 again? Because we're here, right? 1 over 120. It's going to be plus 1 over 120 x to the 7th. Okay. Now, how about this one? Here to here. Am I going to need that one? No, because that's going to be x to the 9th. Understand? So I'm going to just stop there. Yes, Chris?
What do you mean by the first 4 terms? Like,
First 4 terms. 1, 2, 3, 4. Yeah.
and like, why are we needing the other, like the last one?
Because each time, look, if I said it was just these first four, it's not, because these are also contributing seventh powers, right? They are. So because they're contributing, I can't say the last term is this. Last term is that one and that one. But then if I keep multiplying, it's that one and that one and that one. Well, I don't know yet. I need to go to the next one. I just know that if I keep going with the black one, right? The black one went here, here, and here. If I keep going, now I'm at x to the ninth power, which is beyond 4 terms, right? So now let's move to the next one. I'll don't have another color. Maybe I do. I have a green. Oh, I have a purple. Okay. So now we're at purple. This one. So here to here, am I going to want that one? Yeah. Yes, because that's going to be an x to the 7th, right? All right, 7 factorial. Help. And it's going to be minus, right? Minus 1 over 7 factorial, whatever that is, x to the 7th, right? Do I need to keep going with the purple? No, because when I do the purple to the next one, I'm going to get x to the 9th, right? All right. Now, am I done? Well, what would have been the next one here? 9th power of x, right? And that would have gone through here to 1, and that would have been 9th powers, right? So the difference between looking for the first 4 terms and 5 terms is a huge difference, isn't it? Because if I ask for the first 5 terms, then you got to go out to the 9th power, and we would have to keep going for a while, wouldn't we? But do y'all see it could be done, right? I mean, this could be done. It's just, this is better suited for a calculator, isn't it, for a computer, than it is for a human? But we've already said the whole reason we're doing series is so that we can have our computers calculate these things, right? So it makes sense that this should be easy for a computer to do, right? All right, so now we have to put our answers together. So I'm going to eliminate this because I don't need it. So here's where we are. That series, f of x, is approximately x, okay, that's my x term. I got to put these two together, so what's those two together? 5/6 x cubed, okay, and now I've got to put these together. So I've got to get like a common denominator between those, and you already got it? What is it? 41 over 120. X to the 5th. So your common denominator is 120 here. I'm going to trust that answer. Okay, so now what the last step, right, would be to figure out this x to the 7th term, which means you have to put all those constants together with a common denominator. And you should get 461, and this should turn out to be plus. 461 over 5040, x to the 7th plus dot, dot, dot. Well, I'm approximating, so I can stop it there. All right? So this polynomial right here, this 7th degree polynomial, should be a pretty good approximation of this function. Okay? You all happy with that? Multiplication?
That's what you'll want. That's the answer.
Yeah, yeah. Okay. So now let's see this in action. I wish the projector was working. So here's what I'd like for us to do. Estimate I'm going to go from 0 to 1 because it's easy to work with. All right, so we want to estimate that. So this is not something that we would be able to integrate using any technique that we learned this semester. If that were e to the x, we could actually do integration by parts. That would be one of those problems, I call it pulling the rabbit out of the hat, where the integral you're trying to solve for winds up appearing over there, and then you have to move it over. But because of the x squared, not happening, all right? So we're going to estimate the area underneath this curve between 0 and 1 by first converting this into its power series, and we're just going to look at the first 4 terms. So we really want to do the antiderivative of that, right? Of this, okay? So x plus 5/6 x to the third plus 4 over 120 x to the fifth plus 461 over 40 x to the seventh. Okay, we want to take that and we want to integrate that. And that should be easy to integrate, relatively easy? Okay, so that should be 1/2 x squared, right? This one plus 5 over 24 x to the fourth. So I'm just using power rule on these, right? Plus 41 over, I'm going to get a 6 on the bottom, right? Right, 1/6 x to the sixth. So I'll multiply the bottom times 6, I should get 720. Is that right? 7, 6, 1. Did I say 720? Yes. Okay, 720 x to the sixth, and then this last one, I'm not even going to reduce the fraction if it reduces. What's 50, 40 times 8? 40,320 x to the eighth, right? And we're going to integrate this from 0 to 1. Yeah, 0 and 1 made it easy, right? Yeah. All right, so we know that when we plug in 1, it's just going to give us all the coefficients. When we plug in 0, it's going to give us zeros for everything, right? So at the end of the day, this answer will be equal to 1/2 plus 5/4 plus 41 over 720 plus 461 over 40320. I'll let someone crank that out on their calculator.
5 over 24.
Oh, yeah, 24. There's a 2 there. You get your eyes checked.
Will do, sir.
Thank you.
I'll send you the bill.
Okay. All right, someone has checked on their calculator. Is it about 0.778?
Yes.
Okay. 0.7787. Someone give me the decimals. How many decimals do you have? Give me 0.778.
I got my 776.
Oh, 776?
776,
776.
711.
71. Okay. All right. According to Wolfram Alpha, it's 0.778. So, but Wolfram Alpha went out further in the series. Remember, we approximated the series with the first 4 terms. Wolfram Alpha probably went out 15, 20 terms and then calculated. So our answer is an approximation, right? But right now, if I check it with the real answer, we're within like hundredths. Okay, we're off by a few thousandths. So if we wanted more accuracy, we just go further out in the series. Yes?
Is it okay to use like the equal sign instead of the approximation?
For what?
Like over there where you did the integral?
No, technically I should have had approximately. Yeah, thank you. But from here to here we can say equal because this is equal. All right? So on your final, if I tell you to estimate an integral, I will tell you estimate the integral using the first blah blah terms, okay? So I may say, like on this example I would have said, estimate this integral using the first 4 terms of the series. So you would first have to have gone and found the series, so you would have had to have done the multiplication. And once you found the first 4 terms, then you'd come and you'd bring it in here, and then you'd do your integration and get a decimal approximation. Okay? Okay, let's estimate another one. I'm going to still stick with 0 to 1 because 0 to 1 is just so easy to work with. Hold on. Make that secant. Yeah, we would have had, it would have been undefined at 0, so.
We'll do 1 over 10, cosine then.
Yeah, so for here, we don't have a Maclaurin series for secant, but we do for cosine, right?
What is it for?
Yeah, so we're going to first make this look like integral from 0 to 1 of 1 over cosine of x cubed dx, right? And now we need the series expansion for cosine of x cubed, right?
X cubed.
Of x cubed. So what would, let me just write that down over here. What is the series expansion for this? So cosine starts at 1, doesn't it? 1 minus 1 over 2 factorial x squared, right? So what is that thing squared? X to the 6th. And then plus 1 over 4 factorial. What's 4 factorial? 24. Okay. And then x to the, we've done this one, right, earlier?
12.
So 12. And then minus, we'll do one more. 1 over 6 factorial. What's 6 factorial? 720. X to the
24.
18. Plus dot, 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 right? Agreed? Now we have to take that and put it on the bottom. But see, there's a problem with that, isn't there? 1 divided by that, you can't integrate that yet, right? It's 1 over this polynomial. So we actually need to divide it into 1. And this is what that terrible professor was trying to tell his students the other day. How does that, so this right here, let me rewrite it. What we have is this. We have 1 over cosine x cubed, right, according to us, is 1 over 1 minus 1/2 x to the 6th plus 1 over 24 x to the 12th minus 1 over 720 x to the 18th, right? Plus dot, dot, dot. That's what we have. Okay, so in that video, the student was like, can you show me how to get from that first line to the second line? And it doesn't make sense, the algebra doesn't work, right? That's what the student said. And the professor said, no, you just divide 1. Okay, so that's what we're about to do. We're about to divide 1 by this infinite series. All right? That's what we're going to do. I'm going to erase this. So here's how we do it. And I'm going to need a lot of room here, so. Okay, just in case. 1. And on the outside, 1 minus 1/2 x to the 6th plus 1 over 24 x to the 12th minus 1 over 720 x to the 18th plus dot, 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 right? These dot, dot, dots are out here in front of this division. And now I have to divide. Okay, so what do you do? How do you do this? Just the way you normally did it. You started out here, you said, what do you have to multiply 1 by to get 1? 1. Okay, so we multiply by 1. So I'm going to put 1 up here, and now I multiply 1 times that whole thing, right? So I'm going to put 1 times that whole thing is this. 1 minus 1 half x to the 6th plus 1 over, oh, you know what? Hold on, I need some spaces in here. Minus 1 half x to the 6th plus 1 over 24 x to the 12th. I actually need more space than this, but I'm going to just go with this to fit it on camera. X to the 18th, right? And then what do you do once you multiply that through? Come through and subtract that row, right? So I have to come through and subtract. So all my positives become minuses, my minuses become pluses, pluses become minus, minus becomes plus, right? And now I add down. So when I add down, what do I get? 1 half x to the 6th, all right? And then minus 1 over 24 x to the 12th, then over here plus 1 over 720 x to the 18th. Okay, what's the next step with long division? Yeah, go back out to the beginning here and say, what do you have to multiply 1 by to get the next piece? This, right? So I need to multiply it by 1 half x to the 6th. And multiply that through, okay? So what happens when I multiply 1 half x to the 6th times 1? I get 1 half x to the 6th, right? What do I multiply? What do I get when I multiply 1 half x to the 6th times negative 1 half x to the 6th? Add the exponents, right? So minus 1/4 x to the 12th. Ooh, right here, right? Minus 1/4 x to the 12th. What's the next one? Here times here, right? So plus 1 over 48 x to the 18th plus 1 over 48 x to the 18th. And then I would keep going, right? But I think I'll stop there. Come through and subtract this out. So this becomes a minus, this becomes a plus, this becomes a minus. Add straight down, these go away, and then here. 5/24 x to the 12th. Here, uh-oh. I'll get my calculator to help. You had yours, hold on, I'm just looking for my calculator because I feel like I lost it. Oh, there it is. All right. What do you have?
-7 over 360. Yep.
So that's been reduced. Okay? And now you keep going, right? How many terms do we have so far?
2.
We only have 2 terms in this division, right? Let's go 3 terms, okay? Just 3 terms? Okay. So now what do? We go back out to 1 and we say, what do we multiply 1 by to get this? So we multiply by 5 over 24 x to the 12th, right? And then we continue to play this game. 5 over 24 x to the 12th. What's my next term? Negative 5 over 48 x to the what? Where are we? We're here. We're here to here, right? So negative 5 over 48 x to the 18th. Negative 5 over 48 x to the 18th. And then the next term is going to be a bigger power, right? X to the 24th power. Yeah? So we'll stop there. Come through, subtract, becomes plus, right? Let's get this last one. If we can get this last piece, then we'll actually have 4 terms. So I'm trusting all of you could get a common denominator. Yeah, I mean, we all have calculators. 61 over 720. 61 over 720, x to the 18th. And that's what I would have to multiply by, right, on that first step? Okay, so if I multiply, get plus 61 over 720, x to the 18th. Okay. So if you go back and you think about this, right? Think about this. Just ignore that for a moment. Just look at this. This right here was 1 over cosine cubed x, right? Or cosine squared x? Cosine squared? Hey, we're making progress. Either someone stole the projector or they're repairing it. Look at that. I didn't expect to see that. Yeah, that's good. Okay, so this was the original thing. 1 over cosine squared? Cubed x, right? So we rewrote it like this. And that turns into that, right? This turns into this. So I can understand why a student might say, like, algebraically, like, that doesn't make sense. It just doesn't seem like this should turn into that. I don't know. To me, it just doesn't look like it should. What's that? Yeah, it just doesn't look right. But it is, okay? That's it. So we got the first 4 terms, don't we? And we know that we're not going to have any more contributions. If we went one more time, it's all going to be out here. So let's finish this out. So the integral from 0 to 1 of secant of x cubed dx is approximately the integral from 0 to 1 of 1 plus 1/2 x to the 6th plus 5/24 x to the 12th plus 61 over 720 x to the 18th dx, which equals ... You could do the rest of that, right? Just integrate that term by term, plug in 1, plug in 0, you get some answer. Okay? Now, we're going to do one more of these, okay? Because all of these have worked out and they've been pretty nice. I want to do one that's a little bit uglier. Let's just do this one. Integral 0 to 1 of e to the x over cosine x dx. Let's work it out first, and I'll tell you how many terms I want to go. I have to work these out before I give them to you on a test because I have to make sure that the first 4 are achievable within a reasonable amount of time and effort. Sometimes if you just do like the first 2, it's too easy. If you do 4, it's too hard. Just you have to go way too far. All right, so there's the problem, right? We cannot integrate that with any technique that we know. Don't think it'll work. So let's first figure out what e to the x over cosine x is. E to the x, we have a power series for that, right? Yes? And cosine x, we have a power series for that. We need to divide. We need to divide e to the x by the cosine power series. Yes? So I'm going to go ahead and go straight to the division. What goes inside the division box? E to the x, which is 1 plus x plus 1 over 2x squared plus 1 over 6x cubed plus 1 over 24x to the 4th. We'll go one more, plus 1 over 120x to the 5th. That's our power series written out. I've converted our factorials into the numbers, right? And we're dividing that on the outside by the cosine Maclaurin series, which is 1 minus, well, you know what? I'm sick of doing cosine. Are y'all sick of cosine?
No. Cosine's just fine for me.
Let's do sine. Come on, let's just do sine. And you know what? I have to change this. Let's just make this an indefinite integral. Okay, that way we can just,
At least
yeah. So let's make this sine. It's just we've done cosine too many times. So what is the Maclaurin for sine?
1 through 5.
So x minus 1 over 3 factorial, so 6x cubed plus 1 over 5 factorial, which is 120, right? 120 x to the 4th. One more. Fifth thing. Hey, easy, easy. X to the 5th, damn it. Get it right. And then what was 7 factorial? 50, 40, is it really? Golly, things growing. And then x to the 7th plus dot, dot, dot. All right, there we go. This is more interesting. Why is this more interesting?
Because we have 5 terms, and we only have 4 on the sine. 5 terms under the quotient, under the...
Yeah, I mean, yes, there's a different amount, but I'm saying, like, what when we first start this division, like, what's already interesting?
It's alternating. It's alternating.
What do you have to multiply x by to get 1?
1 over x.
1 over x. Right? That's what you've got to do. 1 over x. So our first term up here is 1 over x. So now multiply that through. What's 1 over x times x? 1. Okay, so that gives us the 1. Okay, what's 1 over x times this? Negative 1/6 x squared. So the powers come down. Where do I put it? Underneath the x squared. So minus what? 1/6 x squared, like that. What about the next term? 1 over x times that. So plus 1 over 20 x to the 4th. Put under the x to the 4th. What's the next one? Minus 1 over 50, 40 x to the 6th, right? Okay, I think that's good for now. Coming through and subtracting, minus, plus, minus, plus, right? Okay, now be real careful. Add down. What do you get? First you get x, right? You get x first. This x right there. Okay, what's your next term? Half x squared plus a 6th x squared. 2/3? Plus 2/3 x squared. What's next? 1/6 x cubed. You got to bring everything down. See? Everything's coming down. Here, I feel like we've done that already. 1/30th. Okay, so plus 1/30th x to the 4th plus 1 over 120 x to the 5th plus 1 over 50, 40 x to the 6th.
We have the 6
Did I?
of,
Oh, yes, I stopped there, didn't I? Yeah, I stopped. Let's just not do it. Let's just not do it. Let's just stop right there. There is something here, all right? So, okay, now we go again. What do we multiply x by to get x? 1. Plus 1. Okay, and now 1 times that whole thing, right? Okay, so 1 times that is just going to be x. And then be careful here. That's 1 times x. Now 1 times this, right? Which is going to be it's a cubed, right? So I'm going to put that under the cubes, and it's going to be minus 1/6 x cubed. That's not so bad. Oh, but then I'm going to change the sign and add them, so they aren't going to go away. Here to here. Now, here to here is going to be plus 1 over 120 x to the 5th, and I can stop there, I think. Right? Any questions on that one? Come through and change the signs. Minus, plus, minus, right? Add straight down. So when I add straight down, what do I get? 2/3 x squared plus 1/3 x to the 3rd plus 1/30 x to the 4th, and that one goes away. Got lucky. All right, we go again. We go again. So what do we multiply x by to get 2/3 x squared? 2/3 x. Okay, and then we go again. So when we multiply that times that, we get 2/3 x squared. Okay, what's my next term going to be? Minus 2 over 18, which is 1/9.
X to the 4th.
Minus 1/9 x to the 4th. Minus 1/9 x to the 4th. See how I put it under the fourths? Right? That's this one times that one, right? And I'm going to stop there because my next term is going to be x to the 6th, and I'm not even dealing with x to the 6th. Okay? Change signs. Come down. Minus. That comes down. This becomes a plus. So we will have 1/3 x cubed. All right, 39,270. I'm sure it can be reduced. 13 over 90?
Oh,
Okay, we go again. Yeah, let's go. Let's keep, because these are pretty clean. I mean, these aren't too terrible. What do we multiply x by to get 1/3 x cubed? 1/3 x squared. So plus 1/3 x squared, and then that'll become 1/3 x cubed. What's my next term after that? This will be the last one we wind up doing. It'll be minus 1/18, right? X to the 5th. Oh, we did we? Yeah, because this was gone, right? So minus 1/18 x to the 5th. And then come through and subtract, add. This will be the next piece that drops down, right? So what would my last piece that I need here be in order to turn x into this? Right? 13 over 90 x cubed plus dot, dot, dot. There we go. You know what I find somewhat mind-boggling here? Maybe you don't, but remember I changed it. I was going to originally leave it at 0 to 1, but I took it away because I know that sine of 0 is undefined. Look at our power series. Doesn't our power series reflect that? You could not plug 0 into that power series. That piece right there is going to cause the problem, right? It's kind of amazing that it works that way, but it does. Okay, yeah, so what would our answer to this be? As an indefinite integral, right? As an indefinite integral, we would have, it's the antiderivative plus a constant, right? So we would have to take the antiderivative of this and then add a constant. Agreed?
Yeah.
So I'm going to go ahead and do it. I'm going to add the constant first because I can't add the constant at the very end because it dots out forever. What's the antiderivative of this? Natural log absolute value of x plus antiderivative 1, okay, plus 2/6, so it's going to go back to 1/3 x squared. Here, 1/9 x